Dear students, today our topic is inflorescence. So, what inflorescence is? You know the flower. Flower is basically a modified shoot which is meant for reproduction of plant. Okay, so the flower which is a reproductive part and its arrangement on floral axis is called inflorescence. Okay, in other sense we can say the arrangement of flowers on floral axis, flowers on floral axis. Okay, if we write, we can say the arrangement of flowers on floral axis, which is also called a peduncle. Okay, so this inflorescence is called arrangement of flowers on floral axis, and this inflorescence is of different types. Okay, so what are these types? The types are: number 1, solitary inflorescence. Number 2, racemose inflorescence. Number 3, cymose inflorescence. And number 4, special inflorescence. Okay, these are the types of this inflorescence. That means these are different ways. These are different ways of attachment of flowers on floral axis. These are different ways, like solitary, racemose, cymose, or special type of inflorescence. And I am going to explain these one by one. Again, I am going to explain these one by one. So, first of all, we take solitary inflorescence. Now, what solitary type of inflorescence is? Solitary inflorescence. As the name indicates, solitary. Solitary means single. Okay, when the flower is born singly. If this is the peduncle and this is pedicel and this is flower. If this flower is born singly, or a terminal position of peduncle, then it is called a solitary inflorescence. And this solitary inflorescence, it may be at the tip or at the lateral branch. It may be at the tip or lateral branch. Suppose this is peduncle, this is solitary type of inflorescence. That means this is lateral and this is terminal. Okay, so this solitary inflorescence is of two types. This is of two types. Terminal solitary and lateral solitary. Lateral solitary. Okay, so terminal solitary means the flower flower is born in solitary. The first individual flower is born at terminal position. And lateral solitary is the flower is born, single flower is born, but on lateral position. Okay, so this means flower born on terminal position. Flower born on terminal position. For example, poppy. Okay, and this lateral or axillary. Here flower born on axillary position. Axillary position. For example, petunia. Okay, these are the two examples of solitary inflorescence. The solitary inflorescence is solitary terminal or terminal solitary, lateral solitary or axillary solitary. Okay, this was solitary inflorescence. Solitary inflorescence, it is that type of inflorescence in which flowers are born singly. Flowers are born singly either on terminal position or axillary position. When the flower is born on terminal position, then it is called terminal solitary, or when the flower is born on axillary position, then it is called lateral solitary or axillary solitary. Okay, and the examples are poppy and petunia. Okay, this was about solitary inflorescence. Okay, now we will take racemose type of inflorescence. Now the next one is racemose. Racemose type of inflorescence or indefinite or indeterminate. Indeterminate type of inflorescence. So this racemose type of inflorescence is also called indefinite or indeterminate type of inflorescence. What racemose type of inflorescence is? Okay, so this racemose type of inflorescence is that inflorescence where floral axis continues grow. Continually floral axis grows continuously. Okay, the floral axis grows continuously and the flowers are arranged or attached in acropetal manner. That means if we define this racemose or indefinite or indeterminate type of inflorescence, we can say the growth of floral axis grows continuously. That's why indefinite. Grows continuously. And flowers are born and flowers are born acropetally. That means from base towards apex. Older from base and younger at the apex. That means older at base, younger at apex. Or we can say centripetally. Acropetally or centripetally. Okay? Now, this inflorescence, racemose type of inflorescence, it has indefinite growth. That means the floral axis grows continuously. When the floral axis grows continuously, flowers are born on lateral branches. Flowers are born lateral in acropetal manner. Okay, and this racemose or indefinite or indeterminate type of inflorescence has different types, which I am going to explain here. Now, types of racemose. Types of racemose inflorescence. It has different types. Like number one, racemose inflorescence. Okay. Number one is typical raceme. Typical raceme. Okay. Now, what typical raceme is? Typical raceme is that racemose type of inflorescence in which the pedicellate flower are born on peduncle, or pedicellate flowers are born on floral axis. We can say if this is peduncle, this is pedicel, and this is flower. This is flower, okay? Like this. These are flowers, these are born on peduncle, but the flowers are pedicel. Flowers are pedicellate, that means they possess pedicel. Pedicel is stalk on which flower born. Pedicel stalk-like structure on which this flower is born. Okay, so when typical raceme is that type of racemose inflorescence, we can write here that type of racemose inflorescence, that type of racemose inflorescence in which pedicellate flowers are born. Pedicellate flowers are born on floral axis. Floral axis. Okay. Pedicellate type of flower. This is pedicel. Okay. This is pedicel. And this is flower. When flower has a stalk-like structure attached to it, it is known as pedicellate type of flower. And when this pedicel remains absent and the flower remains directly attached to peduncle, this is called a sessile flower. Okay. So in typical raceme, that type of racemose inflorescence in which pedicellate flowers are born on floral axis. Okay. This is typical raceme type of inflorescence which comes in the racemose inflorescence. Okay. Now second one is spike. Spike type of spike racemose inflorescence. What spike is? Spike is like typical raceme. It's like typical raceme. Arrangement of flowers on pedicel is like that of typical raceme, but the condition is that here the flowers are sessile. Here the flowers remain sessile. In typical raceme condition, there was pedicellate flowers, but in spike type of inflorescence, there are flowers arranged in acropetal manner but are sessile. Okay, I can show you here. Here this is peduncle. These are flowers. These are flowers, okay, but they are sessile. That means the pedicel remains absent. The condition is same in acropetal manner, like in typical raceme. But here the condition is in spike there are sessile flowers which remains attached to the peduncle or which remains attached to the floral axis. So this is spike type of inflorescence, and here the flowers are sessile. Okay, that means the flowers do not represent pedicel. They don't have pedicel. They are without pedicel. That's why these flowers are known as sessile flowers. And when these sessile flowers are arranged in acropetal manner, that type of fluorescence is called spike and spike racemose type of inflorescence. Okay, this was so. If we write, we can say the inflorescence is same as typical raceme, but the flowers but the flowers are sessile. This is the condition. This is the condition. Flowers are sessile. Flowers remain sessile. All the same, this is like typical rhizome. There are flowers arranged in acropetal manner. In spike also there remains flower in acropetal manner. But the condition is that in typical rhizome there was pedicel attached to the flower, and here in spike there is no pedicel and flowers are sessile, which I have shown in this diagram. Okay, this was about spike type of inflorescence which comes in racemose inflorescence. Okay, now we will move to next one. Sorry, the example. I have followed the example. Example of spike. Example of spike. We can say wheat. Amaranthus, acaranthus, etc. Amaranthus, etc. These are the examples of spike. Okay. Now we'll move to catkin type. Third one. Catkin type of inflorescence. Catkin type of which comes in racemose inflorescence. Okay, what catkin is? In this, the peduncle or floral axis, it remains hanging. It remains hanging like this. It is branch. This is peduncle. It remains hanging, and you have observed it. This is catkin type of inflorescence, where this peduncle remains hanging, and to this peduncle the flowers remains attached, which are unisexual and sessile. Okay, sessile and unisexual flowers remains attached to this hanging pedicel and forms a cluster-like structure which is known as catkin. This catkin is basically this cluster-like structure which gets formed here because of assemblage of many sessile unisexual flowers on hanging pedicel. Okay, if we define it, we can say the peduncle or floral axis remains hanging, and small sessile unisexual flowers, large in number, forms cluster-like structure called catkin. As the name indicates, catkin type of inflorescence. Okay. So this catkin type of inflorescence, here peduncle remains hanging, and flowers which are sessile, unisexual and large in number, they form a compact cluster-like structure which is known as catkin. And example we can write here, examples are mulberry, salax, etc. Salax, mulberry, these are examples of this catkin type of inflorescence which comes under racemose type of inflorescence. Okay, this was about catkin type of inflorescence. Now we will move forward. Now the next one is spadix, fourth one. spadix inflorescence. What spadix inflorescence is? I write here diagram. First of all, I will show you diagram. You can see here what spadix is. This spadix, it's some sort of special type of racemose inflorescence in which peduncle remains fleshy. This peduncle, it remains fleshy. This peduncle remains fleshy, covered by green bracket-like structures. Green bracket-like structures known as spathe. And this fleshy peduncle, it possesses these sessile flowers, these large number of sessile flowers, but the tip is sterile. The tip of this peduncle, fleshy peduncle, it is sterile, okay, and is known as appendix. The tip remains sterile and the flowers are not present in this portion. That's why it's known as appendix. It is sterile portion of this peduncle, and the lower portion possesses flowers, large number of sessile flowers, okay, and this peduncle and the flowers, they are covered by green colored bracket like structure known as spathe, okay. So if we say this spadix type of inflorescence, we can say the peduncle remains fleshy and covered by green colored bracket like structure known as spathe. And this peduncle, fleshy peduncle, the tip of peduncle, we can write here, the tip of fleshy peduncle remains sterile and do not possess flowers. The tip of peduncle remains sterile and is known as appendix. So this tip remains sterile. When it is sterile, that means it does not possess flowers. Okay, the peduncle remains fleshy and covered by green colored bracket like structure known as spathe. The tip of peduncle remains sterile and is known as appendix. These flowers, or we can say the flowers, which are sessile and large in number, remains attached to the basal portion of peduncle. The example of the spadix is maize, colocasia, etc. Okay, this was about spadix, in which peduncle remains fleshy, covered by bracket-like structures known as spathe, and this peduncle has upper portion tip sterile, which does not possess flowers and is known as appendix. Okay, and to this peduncle, large number of small sessile flowers are attached at the basal portion. Okay, this was about spadix. Now I will move forward. Now corium, fifth one. Okay, corium type of, what corium type of inflorescence is? I have already learned spadix or catkin or spike or typical rhizome. Now what corium type of inflorescence is? This corium type of inflorescence is, here the flowers remain pedicellate, all have acropetal arrangement, okay, because this is racemose type of inflorescence. We are knowing in racemose type of inflorescence there is acropetal manner of arrangement of flowers on floral axis, okay. So in corium there remains pedicellate flowers, and the pedicel, in some flowers the pedicel remains long, and in some flowers the pedicel remains short. That means in corium type of inflorescence all the flowers are reaching at same height or same position. Although they are arising from lower portion or upper portion, they change their length of pedicel and reach to the common position. I will show you in diagram, okay. If this is peduncle, what this is corium type of inflorescence. You can look here, you can see this is topmost flower and it has short pedicel. This is topmost flower, it has short pedicel, and the flowers which are arising from basal portion, they have long pedicel. Why? They are increasing the length of the pedicel in order to reach the same height, in order to reach the same position. And when this condition appears in a flower, that's known as corium type of inflorescence, okay. So if we write in the corium type of inflorescence, we can say the flowers reaches at same height by changing their length of pedicel. By changing their length of pedicel. By changing their length of pedicel, the lower ones have long pedicel, and upper ones have short, and upper one is short, okay. This was about corium types in which pedicel change in length of pedicel. The flowers change length of pedicel in order to reach the common height, in order to reach the same position, and this is known as corium type of inflorescence. If we write example, we can say candida, capsula, etc. Okay, these are the examples of this corium type of inflorescence, and I hope you are knowing the corium type of inflorescence. Now the next one is umbel type of inflorescence. Now the next one is umbel. What umbel is? I can show diagrammatically. Umbel is all the flowers, they are arising from the same point. They are arising from the same point and move towards different directions but attain the same height, same length. Where from these pedicellate flowers arise? These pedicellate flowers arise, but they attain same length. They attain same length. They are arising from the common point towards different positions, towards different sides, but attain the same length. Okay. So in umbel type of inflorescence, the flowers arises from common point and reaches to different positions but have same length. That means the length of this flower, pedicellate flower, or this flower arising from the common point, they have same length. Okay. So example, centilla. This is the example of umbel type of inflorescence. This was about umbel inflorescence. Now this was almost 6th one, and we will move to 7th one. We'll move to 7th one. This is capitulum or head type of inflorescence. Capitulum or head type of inflorescence. We can say probably 7th one, capitulum or head type of inflorescence. In this, what happens in this? Peduncle becomes saucer type. This peduncle becomes saucer type, and flowers are arising on this. These are all flowers. You can say that in peduncle remains saucer shaped, and flowers arises from this peduncle, in which larger flowers remains towards outside and smaller flowers remains inside. Okay, all the flowers are sessile, but the larger flowers, the large in size flowers, they remains outside, and small sized flowers remains inside. This is known as head or capitulum type of inflorescence. Okay, if we write, we can say the peduncle is saucer shaped, and flowers are born on it with larger size towards outside, and smaller towards inner side, inner side. Okay, and the example is sunflower, marigold, etc. Okay, this is capitulum, in which peduncle remains saucer shaped, and flowers are born on it with larger flowers on outside and small flowers are inside. This is capitulum or head. This was about racemose type of inflorescence. Okay, today I am here concluding this solitary as well as racemose type of inflorescence. In next lecture, in next video, I will explain cymose type of inflorescence as well as special type of inflorescence, and I hope you have understood all this inflorescence, solitary, terminal, axillary, and these types of racemose types of inflorescence. Okay, I hope you have understood it, and we will continue with cymose and special type of racemose in next lecture. Okay, bye.